Discrepancies with recent models of nucleons. Experiments found the mass of quarks make up only about 1% of the proton mass. This is an unexpected finding. The new models of nucleons have been proposed, attempting to explain this. However, these new models contain many mistakes. The new models claim one of three concepts. Concept 1. This claim is related to the relativistic energy mass equivalence, E is equal to mc squared, and says that binding energy has mass, making up the missing 99%. The problem with this claim is a sign error when accounting for the binding energy. Regardless of what type of energy, binding energy must be subtracted from the mass of the individual particles. This is true for all types of energy and for any stable configuration. This sign error creates a significant problem with these models and is a blatant violation of thermodynamics and conservation of energy. Particles held together by binding energy are in a lower energy state than the individual particles. We know this because when a bond is formed, energy is released to the external environment, and to break a bond, external energy must be added to the configuration. Thus, the bound particles are in a lower energy state and at a lower mass. Quantum physics cannot and does not claim to violate conservation of energy. Concept 1, seriously flawed. Concept 2 says that their three quarks are moving at extreme relativistic speeds, inflating the mass of the quarks to make up the missing 99%. But to get this much mass inflation, the quarks need to go absurdly fast, and they would instantly be thrown out of the proton. This problem can only be resolved if the binding energy is stronger than this relativistic energy. In other words, the relativistic energy competes against the binding energy in a tug of war. It doesn't add to it. For the quarks to be stable, the sum of these two conflicting energies must produce a net mass that is less than the mass of the individual parts. Concept 2, seriously flawed. Concept 3 is the addition of hundreds of more nonvalence quarks to make up the mass. However, all of these hundreds of quarks violate the Pauli exclusion principle and the Heisenberg uncertainty principle. Concept 3, seriously flawed. Models of the nucleons must be free of blatant violations of sign errors, thermodynamics, conservation of energy, and modern physics. These new models are severely flawed, unacceptable, and cannot be endorsed as correct.